Now, as I was growing up, my father, who was an utterly inadequate family provider, had the four of us living in a run-down little house that was really designed for only two people. This tiny dump featured a ridiculously undersized kitchen, which also doubled as a laundry. But my dear long-suffering mum somehow managed to make it all work, and in that tiny kitchen she also found room for one of these, an Astor Mickey 4-valve radio, produced in the 1950s. I grew up hearing that little radio each morning as she listened to the talk shows hosted by Norman Banks and Ormsby Wilkins on 3AW. I don't know what happened to it, but a few months ago I decided to get one and began watching for them on eBay. But usually the asking price is more than I was prepared to pay. Mind you, back in 1952 these things cost £20, which was well over a week's wages. Not sure exactly, but probably a lot more. I finally got this one at a reasonable price, but the seller states it doesn't work, although the valves light up, at least some of them. He was just looking in through the back cover and saw some tubes lighting up. This style is known as the breadloaf. It's quite common and usually in this cream colour, which is the same as the one we had back then. It's in quite good condition for this kind of thing. The only damage being a crack in the case and a couple of worn labels and a slightly warped back cover. Everything is totally original, including the unearthed power cord and the aerial wire. And it's quite complete. The only thing missing seems to be one of these little clips up there, which has been replaced by a star washer. Now often these aren't complete, they're usually missing, or quite often they're missing the back cover, so I'm quite pleased with this purchase. It's got an unusual tuning arrangement that I always found interesting as a kid, being different to all the other radios that I was pulling apart back then. Thankfully someone's made available this technical bulletin, which is very legible. It contains a schematic, disassembly instructions, and the alignment procedure, along with parts list, so it should be fairly straightforward to get this unit operating again, I'm hoping. Unfortunately, it has had power applied to it recently, which may have caused some damage, since obviously it's been unused for many years, during which time most of the capacitors will have gone bad. So I'll be reapplying power very carefully. But first I'll open it up, look for some obvious problems and clean it up. The front panel knobs just slide off, and that reveals a little clamp held down by 3 screws. That plate clamps on the dial to the tuning shaft. So I'll undo those 3. So with those bolts off, the plate comes off, and the tuning dial, which is set up for Victoria. Then on the back, I'll remove the 4 screws. So with the screws removed and the clips, we can take the cover off and put some light into it. You can see it's pretty dusty, but everything appears to be complete and original. So now there's 2 more screws on the bottom, which I'll remove to get the chassis out. Right, out she comes. roller speaker. I haven't seen one of them for a long time. We'll stick him up there. This is what I was saying was unusual in the tuning department. This thing here. All radios need a tuned circuit comprising a capacitor and inductor in parallel. And normally, and one of them needs to be varied to select the frequency of the station you want to listen to. Normally it's done with a variable capacitor like this to do the tuning. But this one varies the inductance with these two things. I always thought that was interesting. Okay, there's a lot of dust in there, so we'll clean all that off, clean the case, and go to the next step. Right, that seems to have got rid of most of the top dust. Not that dust though. Speaker seems to be in pretty good nick, one little hole there, but pretty damn good. Underneath, I'll give that another sweep with the vacuum and the brush. But yeah, all original, all these old paper capacitors. Probably a lot of them are bad, and there's only two electrolytics in this here, and a large Ducon condenser there, which is, you know, a bit of a iconic feature of this model. So when I almost certainly replace him, I think I'll insert the replacement inside of it so that it keeps the appearance. Same with this. The case is scrubbed up pretty well. A few stains, I don't even know if it shows up, but yeah, I don't know if I'll bother trying to get those out. I might do more harm than good trying to get rid of them. But there's a slight heat discoloration up there, which is above the output tube and the power supply rectifier. Okay, I'll clean up under there and think about what to do next. Just by the way, this is, you can see with the serial number, HNQ, which is the model that this note applies to. And another thing that's interesting is here there's a little test point, or a little 1-pin socket, which is not shown on the circuit diagram, but it connects to the anode of the output amplifier. Yep, don't know what that's for, but it's there. Right, although I want to, as much as possible, retain the original appearance of this thing, I'm not going to be pedantically obsessed about it, especially when it comes to practical considerations. Like, as I'm moving this around, this is flapping around in the breeze, this is all getting in the road. So I'm going to put inline connectors so that I can just a couple of wires there to a connector, and then to this, so I can just unplug them when they're not needed. It's very easy to revert back to original if required, but just practical, sensible things like that, because otherwise it'll probably end up getting damaged, so I don't want that. That'll be worse than having it less than original. So yeah, that's one thing I'll do. I'll probably do that right now. Okay, after quite a bit of mucking around, I have to run up and get some parts. These are now unpluggable. I'll put 2 pins for the speaker and 3 for this, firstly, so that they can't be mixed up. You don't want to stick 240 volts into your audio output transformer, but also it gives a possible option of putting in a 3-pin plug with earth and earthing the chassis if that proves to be desirable at some time in the future. But as I'm working on it, those things are out of the picture, and this can be fiddled around with a lot more easily. I didn't cut the aerial off. I think what I'll do with that is just, as required, tuck it away in there, or maybe cable tie it to something just so it's out of the way while I'm working on it. And I've also realised that I'll be turning this thing upside down a lot to work underneath, so I don't want to be resting on that, so I'm going to come up with some arrangement like this to support the thing, so I can tilt it upside down and not put any stress on any of the top components. So I'll set that up and we'll see what that looks like. And there's my little support structure. Allows me to turn it upside down with no danger of damaging anything up underneath. It's just 2 blocks of wood clamped onto the edge of the chassis. Now, of course, that means that the whole thing could just slip down, so to make sure that doesn't happen, I've got a screw there and there, just so it can't fall down, and this one had a hole that I could use. So, yeah, that should be pretty secure. And now I can work on that. Now, look inside here. Can't see any obvious problems apart from here. Some of these transformer wires, I don't know if they're visible, are perished. Try and get a better shot of that. I think that's focused. You can see this wire here. There's a few cracks in it, and they're all the ones that go through that hole to the transformer. Mostly seem to be perished on this side. The other side going up to the transformer, not too bad. But one thing which might actually be the reason this thing's not working that I noticed is, not visible this side, but that wire there is, the insulation has actually come off, and it's almost, maybe not quite, shorting to the chassis. But yeah, that might be the problem. Of course, there'll still be, no doubt, capacitor issues, but that might be the main reason it's not working. So we'll have to start setting about testing things. The socket for the light bulb's just basically a coil of wire. But anyway, let's stick some volts into him. Current limit's come on, which indicates it's connecting. And then we can see.
Fuck.
That was alright. The globe was working till it slipped out of my fingers and hit the floor and broke. So here be the schematic, which I have redrawn in a way that makes more sense, at least to me. This way. Perhaps a bit harder to read, the lines are thinner. But what I want to do first is just check the filaments on all of these things. So I want to apply power gradually via a variac to the power supply section and watch these 2 capacitors here charging up, and then test their leakage. It's this guy and this guy, which is the big Duke on condenser, and that one, that's 24 microfarad, this one's 16. So the can is that one, and the one lying horizontal is this one. So I want to test them by bringing up the voltage slowly and seeing how they cope and whether or not they have much leakage. But before I do that, I want to just try turning on the power with the valves in there to see if all the filaments light up. But I don't want power to go to the capacitors yet, so I will try to, yes, if I disconnect the cathode from there, there'll be no voltage going to the capacitors. So let's see how easy it is to do that. Okay, I've just connected the cathode, which had two wires. Well, this wire running to that capacitor, and this resistor went straight to the leg of the tube as well. And the good news is that the perished, that wire there is one of the perished wires. It's not this one here. There's the resistor, and there's the perished, one of the perished wires. That's the one that goes to the capacitor. It doesn't go to the transformer, so it's not the transformer wires that are perished. And this one goes down to the volume control. It's another perished wire, but the actual transformer wires are good, so that's nice to know. The transformer doesn't have a bad wiring in it, so I'll replace that. But while it's off, there'll be plus a lot of volts on the cathode, but hopefully that won't be a problem. It won't go to the filament, will it? We'll only run for a little while just to see that the filaments light up. And the other good news is that this bare wire there is actually stripped. It's meant to be bare because it goes around just through that hole and solters there. It's the one side of the filament winding. It's this earth here. So good. Now, if I apply power, there'll be voltage on the anodes of the tube, but not able to get out through the cathode. Hopefully it won't get into the filament. Well, it'll be short of the ground anyway. I'll just turn on for a little moment just to see that all the tubes light up. It would have been nice to see that little bulb light up as well, but I've busted it. 240 volts going in, drawing 80 milliamps. I can see that tube has a filament. Damn it. Looks like only one valve with a light. Only the rectifier valve. Disappointing, or hopefully, just can't see the others. Oh yeah, there's light in that one. Possibly in that one. I think I can see some light at its base. Oh, and there's sorry, they've all got, all the filaments are going, good. Very hard to see. There is a glow in this one, and there is a glow in this one. Okay, so the tubes do have filaments. I don't know if that's visible in the camera. I can't see anything in the viewfinder, but I can see in this complete darkness that there are glows coming out of each of the four tubes. Now, I was doing this earlier and I rotated the variac out of the way to stop the light from its LCD, making it hard to see the filaments. And as I did it, there was a loud crack and a spark, and in the darkness the only thing I could see was the spark light up the white of this connector here, and I thought somehow it shorted 240 volts onto that. But if you look at the variac, you can see that there is evidence of a unscheduled adverse electrical event. Turn the power off there. So something happened inside this plug. So yeah, this thing is well dodgy and quite illegal these days, I believe, having only one piece of insulation between the conductor and the outside world. So I'm very tempted. I mean, I'll fix this plug up to make sure that it's okay for now, but I'm very tempted to replace it with a earthed 3-lead and connect an earth lead to the frame of the chassis of the radio. Just don't want any surprises with 240 volts anymore. Okay, I'll fix up that plug and then we'll play with capacitors. Yes, one of the screws in there was quite loose, and the strands on the other one were nearly all broken, so I think maybe two of the strands managed to short circuit and explode, but that'll keep it out of trouble for a little while at least. Fortunately, you can still get these little light bulbs to replace the one that I dropped. So, does it work? It does. Whee! Now, for capacitors. So, in anticipation of having to replace this capacitor and all the paper capacitors underneath, plus this upper electro over here, I've got some new electrolytics and a bunch of polyesters to replace the paper ones. We'll see about those, but almost certainly the electrodes are going to be needing to be replaced. This one, I'll test in with my multi-function tester and see how it compares to a brand new one of similar ratings, and I don't expect it to fare well, but also I'd like to just play with trying to reform it. I don't expect that to work either, but let's just have a look at it. So, a new 22 microfarad 450 volts connecting to the tester, and testing 21.6 microfarads for a 22. So yeah, this can test these things obviously, and it's pretty close. Now let's try this old guy. What's that? 44 picofarads. So yeah, it's basically seeing nothing there. Maybe as if this thing's dried out or something. But, I just want to play with reforming first, just to see if this comes back to life in any way, shape or form. I'll set up for that now. But to cut a long story short, I'll leave out the reforming of the capacitor business because it took quite a while and ultimately it didn't really take. But just briefly, I used this power supply over here, DC power supply, and get up to 400 volts out of that, and via a micro ammeter and resistor I could apply voltage to the two capacitors, the two electrolytics, the 24 microfarad and the 16 microfarad, in stages, going up 40 volts in each stage. So I'd connect 40 volts via the ammeter. There'd be an initial kick as the capacitor charged a little, and then a few hundred microamps, which would over the next hour or so gradually drop. So when it got to about 200, I'd bypass the resistor, so it was just directly through the ammeter to the capacitor. It would further drop. When it got to below 100 microamps, I'd go up to the next stage, increasing the voltage by 40 odd volts. And that all seemed to be working. But ultimately, it wouldn't hold a charge, and after 10 minutes testing it again, it was just a dud capacitor. So yeah, long story short, we'll just leave that out. I did also use this power supply with the rectifier with all the valves removed, inject just 40 volts into the 175 volt rail, this one here, and the only current should have been through this 50k and 20k to ground, and at 40 volts that's 600 odd microamps, and that's about what I got. So there weren't any obvious shorts. Of course, that wasn't testing all these paper capacitors. at higher voltage where they might start leaking, but it told me that there wasn't any really fundamental fault and it was safe to proceed with using its own internal power supply. So that's what I did. Right, this capacitor has been restored and the perished bits of wire that connected to it have been replaced with new wire. Now that's all for show. Those wires don't connect to anything. Looking below deck, they go to, there's one of them there, and the other one's there, just got heat shrink on the end. That's round about where they used to go, but no connection. It's been replaced by this one. I've gone to for 33 microfarad, 400 volt. Connects there and to the cathode of the rectifier tube. This other capacitor, the electrolytic here, his lug has been heat shrunk and replaced by this at 22 microfarad, which then goes to this junction point. The output of that resistor from the 195 volts to this junction point, which is 175 volts, connects to the output transformer and to the first valve and into the others. So it's the 175 volt rail, and at the moment that bit of wire there's also perished. It's going to be replaced, but I won't connect it across yet. Just with I'll put in the rectifier tube and see that we get good voltages at those capacitors. We should, well, with no load will be more than 195 volts, but well, at least we'll see a rectifier is rectifying. This here is a current limiter. The bulbs are in series with the power point. When I got this variac, I thought I wouldn't need that anymore. The variac could do everything I needed, but so I rewired it to put the bulbs in parallel with the socket, making it into a dummy load. Turns out for valve gear, that's no good. The variac can't do the job. So I've rewired it back to series. The reason for that is I need full voltage here so that there's enough voltage to get the lamps to come on, the filaments, and enough voltage for the tubes to operate. All I really want to do is limit the current if there's a fault condition, so it's back to a current limiter. So I've got just the 6x4 rectifier tube in there. New capacitors replace the two electrolytics. That's the 175 volt output, which will be more than that with no load, of course. It's not going any further, so all the other capacitors are out of the circuit, all those papers. And we'll just see if we get anything like a couple of 100 volts on the output of the rectifier. Volts are climbing. I'm only sticking in 164. We're getting 179 on the output, so it looks like it is rectifying. I'll take this up to 240 now. Okay, the thing's drawing 60 milliamps, 10 watts, so nothing bad going on. We've got 267 volts, so the rectifier appears to be rectifying. This is all good. Right, I've got 239k in series, and I've sat that across the 175 volt rail to ground. So it gives it a little bit of a load. It should draw about half a watt. And as the filaments light up, we should see this voltage climb nicely to 200 volts. And I'll do that with a analog meter. These things are annoying to look at when the voltage is changing. Let's look at it on a nice analog meter. So I'll turn it on. That should the filaments should light up as the rectifier tube warms up. We should start to get some voltage. go. 250 volts. That's a half amp load. So that's looking pretty good. Dare I put the other tubes in? First I'll connect the 175 volt rail to the rest of the circuit, just with some resistance, just to see if what sort of current that pulls. See how bad the capacitors load up the circuit. Then we'll try it with the valves and the speaker, see if we get any noise out of it. Still, I know the capacitors have to be replaced, I know that, but let's just see if they're not terrible first. This time I've got 1.8k from the 175 volts, now going into the rest of the 175 volts of the radio. So any shorts to ground will be going via that. That will limit things a little bit. We should see, hopefully, we'll get the same voltage there. If we don't get the same voltage, we know we've got an excessive load. Okay, switching on again. And ready to turn off again. Warming up. Okay, so we don't seem to have any bad shorts to ground. That's with the other tubes out, of course, but this stuff isn't, we haven't got any super leaky caps, so let's switch that off and try it with some valves and the speaker in. Right, as before, except we've now got the speaker connected, the other tubes in, the 175 volt rail to the rest of the circuit. I've reduced the resistance down to 390 ohms. Still looking at the voltage on the first power supply capacitor there, and let's see what happens. Voltage is going up. We've got some noise out of the speaker, just a click. The amplifier is working, getting some crackling as I turn the volume knob, but no stations. What if we try tuning? Okay. Well, we know the amplifier is working. The volts come down a lot, but we're limiting our current. So let's switch that off and start looking at replacing paper capacitors. But that was encouraging. The output amplifier seems to be working. We know we've got to replace all those caps, so just time to bite the bullet and do it. And while I'm at it, test resistor values, and that's going to take a lot of hours. I don't know if I'll bother doing that today. I'll do that over the weekend, I think. So after replacing the 10 paper capacitors as well as the 2 electrolytics earlier, 5 resistors and some perished hookup wire, so now it looks like this. The 5 resistors were mostly in this area that needed replacing, but there's the 2 electrolytics, and throughout the place we've got polyester, polypropylene, whatever they are, capacitors. So, time to turn it on and see what happens. So, once again, with the current limiting light bulbs and the variac to control the power going into it initially, with the voltmeter on the first filter capacitor, which should be 195 volts once everything's settled down, and this one on the what should be the 175 volts on the second capacitor after going through this 450 ohm resistor. So yeah, let's stick some bolts in. Right. We haven't got all the volts we should have, but maybe that's because these bulbs are limiting it too much. You see there, on very dimly. But it's drawing 25.6 watts. Now this thing's supposed to draw 40 watts, so I think maybe it's safe to go direct without these bulbs, so I'll try that now. Turn it off. Direct into the variac. $29 watts, 35. Sounds a bit more like a radio. Only got about 200, we haven't got our 200 volts though. Drawing the 40 watts that it should now. That should be about 195, this should be about 175, so a little bit low, but the power it's drawing seems about right. 40 watts. The hum there, but turning the tuner has no effect, except for the occasional crackle. So what's that mean? Possibly other valves are dead besides the rectifier and the amplifier, they seem good, but the two front end valves might be sus, a 6BE6 and a 6AD8 I think. These dudes. Obviously the rectifier is working, obviously the amplifier is working, but these two are sus, or something in this area. I'm going to have to learn a bit about radio debugging now, aren't I? Signal injecting and what to look for on an oscilloscope. Okay, off to do a bit of study. So we've suffered a setback here. The speaker output from the audio output transformer has broken off, and I can't even see it. I can just feel where it connects to there. So what I'm thinking of doing is getting a tag strip like that two-way one there and soldering it onto the top and bringing these wires, including some whatever I can hopefully repair on that one, up to the tag strip, and then have the speakers run from the tag and cover all that with hot snot or something once I'm satisfied that it's a good connection. Bummer. So I've got to go and get a tag strip because I don't have any of that stuff lying around here. So I've got a little tag strip, and I think I'll just try and solder it onto the top of that audio output transformer. Now, being metal like that, it's going to be hard work for this soldering iron to keep the heat up. But hang on, that's not a soldering iron. This is a soldering iron. That will do the job. So there's my little repair. I managed to hook onto that 0.5 millimetre or whatever was sticking out. Tag strip up there. The ground pin, this wire could go up to there, but I'll just leave well enough alone. And speaker making some crackling noises, very encouraging. No radio noises, but okay, so all we need to do now is put some hot snot over that to make it solid, like that. It looks like a fairly successful repair. Now we should have to continue with the troubleshooting. Why aren't we hearing radio noises coming out of this? Now, this is where my experience of these things is very limiting. I know that I understand how the rectifier and the output amplifier works here, but tuning circuits, yeah, maybe. Intermediate frequency amplifiers, radio frequency amplifiers, mixers, local oscillators, detectors, automatic gain control, that's all happening around here somewhere, and I don't know much at all about that stuff, so I'm flying in the dark. But I know I've done a bit of reading and I know a few things to look for, so I'll get started on that. There's some sort of oscillation happening. Here you can hear it. almost a motorboating effect, but and then almost radio sound up here. But both of these tubes are hot to the touch, and these ones, this one's slightly warm, this one's quite cold, the 6AD8. 6BE6s, yeah, just slightly warm, nowhere near as hot as these two. So I'm suspecting that maybe the 6BE6 is a little bit alive, because it does react to, it's at the front end of things, and it does react to changes on this tuning system. And in any case, I can't test it because I haven't got another one. But I was able to get a new 6AD8. Don't know what the way it's got a cross through it, but let's have a look. I believe it's brand new. There we go. 6AD8. So let's swap him and see what happens. Okay, applying power. Turn the volume up full. Always out of the speaker, a few crackles and pops, but nothing like a radio yet. Okay, those two are both still hot, and this one is cold. That's the next thing to check, see that there really is volts getting to the filament pins on these, and that the tubes have a some resistance on the filament pins. Well, both of these valves check out about 3 point something ohms on the filament pins, so I assume that's about right. But this is connected to the filament pins of the 6AD8 socket, and clearly there's volts, the correct voltage there. Now, being concerned that these two tubes seem to be not very warm yet glow in the filaments, whereas these two got quite hot. Now, the rectifier and the output power amplifier obviously deal with more power than the front end, so yes, they should get hotter. But these were bloody cold and these were bloody hot, and I just didn't think that was right. So I got onto the electrically erasable video blog forum and asked about it, and most people seem to think, yeah, well, it's pretty normal that these would be very hot. They didn't actually say that you shouldn't feel any heat there, but they started suggesting I look at other things, and things that I probably wouldn't have got around to looking at till long after I'd gone to the trouble of replacing those tubes, because I was fixated on them being the problem. And the things they got me to check were things like that the coils on the IF transformers weren't open circuit, and they weren't. They all measured about 15 ohms. And another suggestion was to check that these coils in the tuner were not open circuit, and that was a very valuable suggestion, because this one here measured about 15 ohms again, but this one, the big one, was open circuit. And one of the other things they'd got me to check was put an oscilloscope on the local oscillator output on the 6BE6, which is pin 1 there, and this is the coil that is open. So yes, that's a pretty nasty problem, because if there's a fault in that, it's going to be very hard to fix. There are very fine wires. I mean, the whole thing's embedded in wax, and there are very fine wires leading to these two lugs here, which then go underneath these rings to these two lugs, which go down into the rest of the tuner. And as far as I can tell, the wires come from the lugs and they're intact until they enter the wax of the coil. So if there's an open, it's inside the coil somewhere, which could be quite hard to fix. But they then suggested on the EEV blog forum to heat it to melt the wax off while unwinding it to find the fault, which is, I guess, what I'll have to try next. So there is one hope, because there's a little lump under there which may be where the coil burnt out and ruptured through the wax. I can't tell till I get it off. It's going to be a very delicate operation. I'm not sure I won't screw it up, but I'll have a go. So I've removed the open circuit local oscillator coil, melted the wax off using the hot air pencil gun thing on my soldering station, and there's still a couple of blobs of glue at each end, which using xylene and cotton buds I was able to rub off, and exposed the brake, which I found on the third turn from the end. You can see there's a slight gap there where the turn should be, and the two sides of the brake are splayed out to the side. So I've got some wire wrap wire, which is pretty thin but still quite a bit thicker than this wire, but that's what I had at hand. Stuck a half a turn across the top and soldered it to both sides of the brake. Then covered it in hot melt glue, and then re-waxed it, and then reinstalled it in the radio. So yeah, looking good. Let's see what happens. Repaired tuning coil for the local oscillator has been reinstalled, and now the moment of truth. Valves are all seated. Let's see what happens. Ooh! Band on the run. Bit staticky, but no, don't understand that bloke. Bloody football.
This, I think, is really ugly. I think it's an illustration of the worst aspects of sexuality performed on television.
Astor Mickey rides again. Beautiful. Very, very pleased with this. So there's Astor Mickey working again in all its glory. Looks rather nice. And I've got this crack on the top, it's only a bad spot. Still got to put the back on. And obviously there's going to be more to do. It's not perfect yet. I need to almost certainly line the IF and adjust the trimmer capacitors on the tuning coils, since I've changed the coil around a bit. I may even have that coil in backwards. It's important which way around it goes. I forgot to check that. But for now, there she is. Yeah, the dial's interesting. The old radio stations from when I was a kid, well, 3AR and 3LO still exist, but they've got different names. They're government stations. 3HT, that never existed while I was around, or 3HO, sorry. 3UZ, gone. 3DB, gone. 3HT, that never existed when I was a kid. KZ, gone. ZL, didn't exist. AW still exists, but it's changed frequency, it's down here now. 3XY, 3AK, also gone. So the only station there that still has its call sign is 3AW, and that's It's moved frequencies anyway, so that dial's pretty much useless information-wise. All the other smaller stations are probably Tasmania or regional Victoria, and I don't know anything about those. So, there's Astor Mickey. I hope you enjoyed seeing it getting prepared. Catch you later.